So good morning. I will request person to mute. Mute. Hello. Yes, I think I'm audible to you all. It was little bit disturbance, so I could not focus. So, should we start? Any one of you can confirm? Yes, sir. Okay, great. So, thank you for joining us. I am Sunil Chore, Chairman and Managing Director of Simusoft Technologies, and I have done my engineering in electronics. Then I did my mechatronics post graduation. Then I did my MBA in production and management, and now pursuing PhD from simulation modeling. And we have a team size of 25 young engineers. Those are working in the cutting edge technologies like AI robotics, digital twin, uh, then artificial intelligence, GPU based AI server, and computer aided manufacturing, factory modeling. So these all are new age technologies on which we are focusing, and we are providing services to industries, service organizations, and also we are also into the business of taking this benefit to educational engineering clients like engineering institutes, then skill educational institutes, and then now certain extent we are trying to build our schools also. So artificial intelligence, IoT, robotics, all put together, what kind of a new automation technologies are coming in. In fact, we are also working on drone technology also and integrate drones to artificial intelligence. So I feel very, proud to tell you that within just 2-3 years, we have established more than 3 to 5 center of excellences across India. I will also try to show some glimpse of those center of excellences, how that transformation is happening in educational institutes, how students are acquiring these new skills and building their careers effectively in this cutting edge technologies. So with this, I will first of all introduce our first center of excellence in Industry 4.0. It has simulation centers including automation studio, RoboDK, visual component, all put together, then CAM technology. So it is saving huge cost. The theme is that they have to learn virtually in simulation lab and then get their codes into actual hardware. So as if 30 CNC machine, 30 robots, we can't afford to give to the students. So in simulation lab, we teach students how to practice on simulation, and then similarly we take them to hardware section. So whatever relation code they have developed, they can put into hardware and make it and feel it that whatever they had done virtually, they are realizing in hardware. So first center I would like to put before you, so that you will come to know that how robotics we have justified in virtually also in hardware form also. आवाज जातो का तिकडं ऑडियन्सला? नाही. Can you hear the sounds?
Yes, sir.
So this was the. तिकडे थांबतो का? तुला ते कसं लावायचं ते कळेल का? तिथं थांब, म्हणजे इको आहे ना त्या हा टेबलावरती तिथं. Yes. So this was our first center of excellence. You must have seen that how that simulation lab was there, which can allow students to virtually get their ideas into realization and then test on actual hardware. Next center I would like to showcase you of NTTC Nagaland, which is far in east, and still the students are doing really great jobs there. We have seen institutes from Nagaland Institute of Technology like NIT Nagaland. They also are taking the benefit of this laboratory, and tremendous way they are using RoboDK, and they are implementing that RoboDK software later on their hardware also. So this is Nagaland lab. Okay. I mean, are you able to hear the sound?
We are in place, but we are not able to hear the video sounds.
Okay. Anyway, so I will correct. ते आणतो का इकडे? तुमच्या यातून आवाज आहे का इथं केलेले? नाही, तुम्ही इथं लावून तिथं आवाज जाईल. तुमचं साऊंड चालू राहिलं ना, इथं आवाज जाईल. Just a minute. YouTube minute. Can you hear the sound now? Hello?
Yes, sir, you are audible.
Yes, sir.
Sir, you are audible. Video is not audible.
अरे मूर्ख माणसा, माझा व्हिडिओ येतो का नाही ऐकू बघ ना तिकडं. तुझा माईक ऑन ठेवावा लागेल त्यासाठी. माईक ऑन आहे ना? चालू करतो फक्त माईक येते का रे? ठीक आहे. तुम्ही करतो चालू, तुमचा होतोय चालू. याचा आवाज येतो तुला? हा ठीक आहे. तुमची स्क्रीन शेअर नाही. तुमची स्क्रीन शेअर नाही तुम्ही लावली होती. मी शेअर करतो, तुमचा होता माईक आणि व्हिडिओ चालू ठेव.
Basically, something like one more. So, crossing borders of Maharashtra, we have established one more data park, center of excellence. Welcome. The honorable chief minister of Saudi. Nothing like here, and then we will get it down and still set aside something.
Anyway, so my point is getting this simulation technology, which is very affordable for everyone, and later on with a very minimal hardware, they can execute their ideas in terms of whatever they have understood. Similarly, now what we are trying to work on digital twin aspect also. So later on, we have also integrated this simulation environment with actual hardware, and we are using the visual component for that. Later on, after if we get some time, we will showcase you that how visual component is used one step ahead to RoboDK. So till now we were only thinking about taking coordinates, teaching robot, generate programs, and then giving it to actual hardware. But now AI is also playing very good role. So how do you connect your like Jetson Nano or Raspberry Pi to your hardware? That is again a very good interesting part that nowadays teachers are wanting to know that how exactly this is happening. And now this engineering is no more ownership on any particular company or particular department. So if you see computer engineering department, they are keen to know how AI is integrated with robotic automation. Mechanical engineering students, they are very keen to know how do they learn AI and then integrate their knowledge with computer engineering, and then combine with the combined efforts. how do they can build a comprehensive multidisciplinary system in automation which can really help to society and also to build their career. So today we will start with RoboDK. Then we have built some examples, ready-made examples we have built. We are also giving some services, simulation-based services to industry. That 2-3 case studies also will be able to showcase you. And then later on, if time permits, we will take question and answer session with which we will be able to clarify your most of the doubts. So this is how we build our simulation. Uh, these are some of the photographs which would like to showcase you. So at a time, uh, 30, 40 students will be able to work on this simulation environment. Uh, are you able to see the screen?
Yes, sir.
Yeah. So this is our NTTC Nagaland lab. So 30 students, they are given training on simulation, and then later on they are taken to actual hardware. Then we have one more such a laboratory, KBP College of Engineering Satara. Similarly, again, students are exposed on simulation environment, and later on they can. So 30 computers, one robot is more than enough to get them feel that how their robotic system works, and how do they generate the program and then take actual program to robot. Next. So these are the some ideas where you can save crores of rupees of your educational institutes, not compromising with the technology and taking the same efforts flawlessly to the students. Now I will request Abhishek actually to take actual tour of RoboDK, and once we build some 2-3 simulation model, then later on we will showcase you some of the real case studies also what we had built for companies like Mondelez, and we will also showcase you some models in visual component as well. Yes, Abhishek.
Yes, thank you, sir. Am I audible to you all? Hello?
Yes, sir.
Okay, I will share my screen and we will have the tour of RoboDK. My screen is visible or not?
Yes, sir.
Okay, clearly visible to you? Okay. So we start with the RoboDK. So firstly, why RoboDK we use? The basic reason behind using these softwares is instead of investing lakhs of money in single one robot, we can buy a multiple simulation software in that lakhs of money. So we can uh, reach to multiple robots by the softwares. Okay. So in RoboDK we have मल्टीपल मैन्युफैक्चरर्स जितने भी वर्ल्ड में रोबोट्स मैन्युफैक्चर है उन सबके जितने भी टाइप के रोबोट है वी कैन एक्सेस दैट रोबोट फ्रॉम द रोबोटिक सॉफ्टवेयर. That's why we are using the robotic software specifically to understand how robot work, how we can program them, how the what is the anatomy of robot. That's why we use the robotic software. So firstly, I introduce you the basic toolbar. What is the software? So here we have our toolbar from where we can uh, uh, add the robot or the create a program, create a simulation for a robot. So first we have here the files, then we have our online library. We have the save button here to save. Here we have the undo and redo buttons, so we can Then we have here add frames, add target, fit all. Okay. So when we go for a program, I will explain that. So firstly, we will open the online library. As I said, कि यहाँ पे जितने भी वर्ल्ड वाइड रोबोट मैन्युफैक्चरर्स है, we can access them. So around more than 500 robots we have here by every event, starting BB, then KUKA, then we have Dobots, we have Elephant Robots, we have Ipson, we have Fanuc, we have Mitsubishi, we have Yamaha, then KUKA, all over the world robot manufacturer are present here. Then in types, we have the robot specifically from 3 degree of freedom up to 7 degree of freedoms. We can divide them in specific like SCARAs, AGVs, conveyors. Okay. Then we have here multiple tools like end effectors which we use for a specific application like laser cutting tools. We have the cameras, we have the 3D printing nozzles, we have the multiple grippers, gripper, 3D jaw gripper, we have the suction grippers, we have the spray guns, the grinding tools, and then some drilling tools and all the attachment we have here. We have the spot welding guns. Other than that, we can also see here that we have some 3D models like box. We have different shapes over here. We can also import the pallets. So by using this software, we can simulate the actual industrial application in this software. So we will do one small program. So I will take this ABB robot. I will click on download. My robot is downloaded, and I will just open it from here. And my robot is, you can see my robot is in this 3D environment. So this 3D environment and the software is totally Windows friendly and user friendly. We can use the Windows shortcut keys. So for fast working. So from here we can change the isometric in we can see the robot in different views like top view, in front, and we can also see by clicking on mouse and also rotate the robot in any direction, place it anywhere. So now we will create one small program. Firstly, I will attach one end effector to it. I will open again my online library, and here in types I go in tool. Then I will select one laser cutter. Okay, and you see my end effector, my tool is directly attached to the robot. So I have not done anything to any other process to attach my tool to the robot. uh, that's why we call it user friendly. And at here station tree, you can see the whatever activities are going here. We can see here I imported my robot, I imported my laser cutter tool. So now what I will do, I will give the instructions to the robot. Like I will move this robot. So how I move? By clicking on, double clicking on this robot, I can have access to the control panel. As we know, in a real robot, we have teach pendant to move the robot, to program the robot. Like that, here we have this control panel. In this, we have tool frame, we have reference frame, we have both here, and down here at the joint axis job. By moving this sliders, I can move my robot in all its 6 degrees of freedoms. And when I am moving this robot, okay, so this is how I move the robot. And by clicking the home button, I can actually get my robot to its home position and align it to the original position. So what I will do, I will do create one target adding basic program. So I have at my home position, I will add my first target. So by adding target, the all the coordinates here we have are saved, are as a home position. I will rename it to the home. So whenever I click at the home target, my robot goes to the home position as this position. Now I will move my robot to the second point from home. I have this point B. I will rename it to the point 2. Okay. And then I will go downward. Add one point. Rename it by point 3. Again, I will add one target. Rename it by point. So as I had told you, it is a Windows friendly software. I am renaming it from directly pressing my function button F2, or we can rename it by left click on the targets. So when I go click on my targets, my robot is moving on that targets that I teach to it. Okay. So I have my targets added. I have given the coordinates to the robot. So now I will create a program. To create a program, I will add one empty file. So I have my empty file over here at the station tree. So then I will start adding my points to my program. So what I will do, click on the my empty program file. I will hold my control button, and then I select my first point is a home point, and then give the joint movement to the robot. As I have done this process, you will see here some set points and target are added to my program. So I have added my home position in my program. Likewise, I add my point number 2, give it a joint movement. Point number 3, point number 4, and again I will go to my home position. Sorry. So, but when I was adding my points, you can see here one yellow line was created. Okay, we can see here one yellow line. So this yellow line is basically the path which robot is going to be follow. So here I have created a program. Okay, by clicking on this program, my robot will be moved as I given the instruction to it. So robot are the mainly designed to work repetitively. They do task repetitively. So to perform this task repetitively in loop, So I will here press the loop button and again I play my program. So my robot will do the repetitive task in multiple times. So this is the basic program we have created here. Then what we will do, we will I will delete this program with these targets and the gripper. What I will do, I will change my application to the spray painting. So I will open my local file. I have my spray paint tool downloaded already. I can access that from my local files. So I will select my tool, open the tool. So my tool is attached to the robot. And what I will do, I will open my own library and here I will take one shape or a box or object. So what I will do, I have this RoboDK plate, name plate, and open this plate in software. So here we can see my plate. It's placed below the robot. It's at the base of the robot. So as I can access the control panel of this robot, likewise I can move this plate in this environment anywhere I want to place it. So by double clicking on the plate, I have the all the settings to move this plate. By adjusting the values in the coordinate system, I can move my plate. So what I will do, I will see my robot from the top angle as I have to place this plate properly in front of this robot. So here I have, I will just lift this plate in here. So okay. We can also apply the scales so we can increase or decrease the size of the our object or shapes. Also, I can change the color of my objects. So what I will do, I will go in programs and select the option teach targets on surface. We can also use the shortcuts like Control Shift T, which will activate this command. By clicking on teach target on surface, I have here one control panel open, which shows the my command is activated. So when I move my robot on the surface of this plate, the cursor where I am moving on the surface of this plate, my robot is moving along with. So to add the targets, I just basically simply click on that surface. Okay. So as I was clicking on the surface, here you can see at station tree, my targets are added. This is how I can use the spray painting application, and then I will simply create one program, add all the targets to my program. and I can run that. This is how we can use for spray painting applications. And other than that, I can we have one station over here where we simulate the whole factory setup of Cadbury. So the problem statement was to segregate the pallets uh, into section which are the okay or not okay. So okay pallets are pallets which are fully empty, and not okay are the pallets they have some Cadbury stick on the pallets. So we have designed this in RoboDK. As I run the main program, first it will pick the pallet from the conveyor. Then it will empty the pallet in the box, Cadbury, and then it will show the pallet to the camera. So here we using the robot vision system in simulation. As camera detected there is nothing on the pallet, the green signal blinks and the pallet goes in OK line. Then again it will go for a second pallet. The same process it will follow. It will empty first, tap the pallet, empty all the Cadbury's all in the box. It will show the camera. Camera will detect anything is there. So there is some pieces of Cadbury over there. It indicated red and put the pallet in not okay station. So this is how we have created this whole process in simulation. In part of digital twin, like so we have done here one application of digital twin. I will show you. So this is the application of digital twin. So you can see here we have imported some of the 3D models like this table, we have this chair, we have this screens, we have this pallet stand and weighing gauge, we have feeders. These 3D models we can import in the software, so we can simulate the actual whole thing what we have in physical. So in previous videos you have seen the Scara robot cell. So this is a digital twin of that Scara robot cell we have created here. We have imported the 3D model of its table. We have here the displays. We have the uh, pallets. Then we have here the working conveyor. We have the feeders. Everything we have imported and here. So this this application is for the color based sorting. So when I start my cycle 1, so here you see my first object comes on the conveyor, which is a blue block. Robot will pick it and then place on the color detection sensor, and after detection it will place it on its origin place. Then my second block comes and the same process repeats. It will detect its color and then it's placed in its original place. So this is how we can perform a digital twin in this RoboDK software, importing our actual 3D models and creating a real life application in simulation for testing purposes. So main reason of using this software is to test our programs, our any application we are working on. So in real life we cannot face any errors in program. Then now we will see one magic of RoboDK. We have seen VR until that we have seen the all things like digital twin, how we can simulate the actual factory setup or assembly setup or any setup in RoboDK. But what RoboDK can capable? So we have created one program of gesture control. So by con- gesture control, I can actuate my robot. So here I have one program. So this is a basic pick and place program, but for actuation of to actuate this robot, I am using the gesture control. So as I click on my program, I have access to my camera. Okay, if is this visible or not? Hello.
Yes, sir.
Okay. So I have here my laptop camera. When I so this is a gesture control. जब मैं यहाँ पे क्लोज दिखाता हूँ मेरा हाथ, so my robot is at its home position 1. I will go to the position number 2. Okay, pick it and then come to my position. Okay, this is how we can do simulation in RoboDK. So this is a gesture control. So what I have done here, I have installed the all required drivers, the media pipe. I have taken the support of OpenCV. Here I have my Python program. I have connected my OpenCV, then media pipe and RoboDK. All these three things are connected together to perform this task. This is how we can use AI or Python in RoboDK. So also we have one application over here in which we have one robot. So here you can see I have my robot over here. Okay, and in actual we also have a robot over here. So I have created one pick and place program. So firstly I will run my program. As my program is working on RoboDK software, like, likewise my robot is moving. So what I have did here, I have connected my RoboDK software and the robot by simple installing 2 or 3 drivers. So what the drivers do? The drivers help me to communicate with the robot processor and the RoboDK. So by communicating with both of them, I can program my robot here. I will test all the things, whether my program is working properly or not, or it is getting some errors. And then by testing, I will upload that program directly to my robot. So this way, this can be also do in RoboDK. So this is all things we can do in RoboDK. If you have any question regarding RoboDK, so we are open to speak now. If you have any doubts or anything, you can ask. This is all about the RoboDK we can do.
Hello,
Yes, ma'am.
can you listen me? Good morning,
Yes,
sir. Ranjana
yes,
here.
ma'am. Yes, ma'am.
My question is that RoboDK is available online platform to easily install, or is it required any license?
Ma'am, firstly, it is a open source software, but in student version, it have a student version and license version. So when you get the student version, it is totally free for you. But in student version, you have some limitations. So you can perform only 5 tasks. Like uh, you can get the 5 object. You can only access to the one robot at a time. You can do like you have some limitations over there. You can do only 5 things over there. When you buy the license software, you are open to the robotics world.
Okay. Thank you.
Yes, ma'am. Any other doubts?
Hello, sir.
Yes, sir.
Can we have a simulation study done on robotic software?
Yes, your voice is breaking, sir.
Can we have a simulation study done on the robotic software?
Simulation study in the sense of what, sir? I didn't understand your question.
Let's say if we have a shop floor type of a simulation, and if I want to calculate the delay time, arrival time, expected time of delay, all this simulation study.
Okay. So we have another software for that. In the RoboDK, we can only simulate the things. For actual, you want if you want the actual time or time required for the process data, we can use the visual components.
Okay.
We have the overview of that software. After that, you can see over there. Any doubts regarding RoboDK? Yes. Yes, sir.
Hello.
Yes.
Please check the message box. I have posted a lot of questions there. Please
Okay,
answer
okay,
one
okay,
by
okay. Yes, sir. Yes, sir. Okay.
Can you see that?
Yes, sir. I also have one doubt.
Yes, sir.
Yeah. So suppose I have to make a walking robot. You can say on 2 legs. I have to design 2 arms. Okay.
Yes.
And I have,
Sorry, sir, your voice was breaking. Can you repeat your question?
yeah. So am I audible now?
Yes, sir. You are audible now clearly.
Yeah. So suppose I have to make like a balancing robot, walking balancing robot. So
Okay.
it should walk to and fro, or as per my instructions there. So
Okay.
is it able to designable here? Can we design that type of robot in this RoboDK?
No, sir. We can't design robots in RoboDK. We can simulate the robotics application in RoboDK.
Okay, you mean to say only one functionality we can check here with the hardware setup, right?
Yes, sir. Yes, sir.
Okay. Good. Got it.
Manoj sir, you have asked how did you use the AI? So there are some drivers to install in RoboDK. So we can use AI or integrate our cameras or sensors to the RoboDK. So I have installed that drive to my RoboDK like RoboDK API. I will show you. My screen is visible or not, sir? Do you see my screen?
Visible, sir.
Okay. So I will open my gesture control project. So over here I have given some Python programs here, and in this main file I have my all drivers installed, like Python programming for Python, and then to access my camera, I have here. I have take the support of OpenCV. I have my media pipe to communicate between the camera and the RoboDK, and I have over here a RoboDK, and then I have created the program here. So first is I have given two targets. So basically, first is a pick, and second is the place target. And then I define my hand gestures, like my close hand, pointer finger, middle finger, like that. Then by using the webcam, here I have my webcam, and then below that I have my robot coordinates. So when I show my first finger, it will go to the pick pick place. When I show my second finger, it will activate the suction. When I show the third finger, it will disactivate the suction and drop the object at a given place. And when I close my arm, so it will go to its original place. This is likewise.
Even you can take help of ChatGPT also for some ready-made API you can call, with which this becomes easier, because playing with actual robot will be much difficult. But here it will be very easy since it is on virtual environment. So and anyway that camera is also at your laptop, so you don't need to buy separate hardware also. So you will feel that camera is connected to your robot. That way it can correlate. So you can test all this program and then integrate artificial intelligence ready-made codes with RoboDK, which will boost the confidence. Even you can give some projects to the students also, like color sorting, uh, vision sortings, like say uh, green apple or banana, so detecting the fruits. If you have DeepMind softwares from Google, you can take that benefit. So many ready-made APIs are also available. You can integrate with this and then check your own or validate your own AI system using RoboDK. Yes, sir.
Yes. Any other doubts, sir?
I need to think of topic related to AI with robotics for a PDF. Can you suggest something? Yeah, we just spoke now.
The APIs and the drivers are available.
Yeah.
Yes, sir. There is a question from my side here.
Yes, sir.
Like, suppose I have to integrate a camera functionality. I have making an arm, robotic arm, and suppose I want to make like take input from the camera, and based on that, I want my robotic hand or that arm to get functional. Like suppose I have taken input from the camera. This my camera is suppose somewhere else, and now I have to I want my robotic hand to work according that camera input. So is that possible in the software?
No, actually, again, I'm trying to tell you that this product is to validate your programs. Now, what hardware you have and how do you integrate, that is really, your concern. As just now we have shown you that robot magician with us. Now, what application you have, that entire virtually you can validate on software. Now, how do you actually integrate with your hardware? That architecture we don't.
Suppose like it is just like suppose a rover that we are designing, and based on like it's just to walk. The rover is just walking on a land surface, and sometimes there is like a rough surface, a rough terrain. It faces. So now I have to like take the rough terrain or like a land area from input from the camera, and I want my rover to adjust it from like a walking. It's a walking a rover like. Like what I'm trying to say.
I understood, Professor. That is the altogether different project based on cross what you're talking about. You may use lidar or other system for that. Here, I'll tell you this all I'm talking about industrial robots. That how do you use the existing robot, for example, Mitsubishi, Fanu, Eskawa, Kuka, and if you want to, validate your future applications, this is the canvas for that. Robotic is canvas for that. For example, if you want to teach students that how do you do pick and place using industrial robot, not only virtual robot, then you can make them feel as if it is Fanuc robot, Kuka robot, and then teach to the student basic robots, and then their architect, how to teach the robot, how to generate the program, and then take you to the actual robotic system. Robotic software is a cost-saving product, which should give you feel that buying 30, 40 robot arm is not worth for any institutes. So this provides you virtual canvas to apply those things in virtual environment.
Yeah, okay.
Yeah.
Got it.
We are Manoj Saini. We are not here to pass on any idea. We are here to show the tool that how do you use it. It is up to you. So let us not become too much personal on this because so many other people are also waiting. So I think if you have any particular doubts regarding RoboDK, you please ask. You can connect with us separately for your any research topic, or if you want any help in this software, how do you integrate our software with your hardware, that separate service we can provide you. Any questions from others? Okay, so now you have seen how individual robots can be programmed. Now I would like to show you that how a robot.
I have only one question.
Yes.
Sir, can we integrate our own robot which we are designing in RoboDK?
No, RoboDK has ready-made libraries. So it has got 140 industrial robots. So I think that only you can play around with.
Yes, sir, thank you.
Yeah. So I would like to showcase you one more applications that individually you have seen how robot can be programmed, how robot can be taught. Now I'll tell you along with robot how man can be aligned, like man machinery is, then methods and measurements, how entire factory can be designed and robot can one of the part of that factory. That is visual component product. I will request Arti to showcase you in a brief so that individually you have seen robot. Now you can see robot operating with entire in shop floor. You can operate with conveyors, then levers in the shifts, in CNC machine. So this is one additional step ahead which will help you to understand how robot can perform in factory.
Thank you, sir. So I'll just share my screen. Is it visible? Okay. So basically, Visual Components is a 3D simulation software where we design our factory, simulate it, and optimize it by our own way. So this is its basic interface where we have this upper ribbon. Here we have many home processes, modeling, and program drawings. And at the left side we have e-catalogs where we have different types of manufacturers available with their components like robots, conveyors, and machines, means CNC, lathe. All we can see in e-catalog here. So as Abhishek sir told you about the RoboDK, in RoboDK what we actually do is we teach the robot how to pick and place the component. But in Visual Components, we don't teach. We actually see how in real world factory the robot work. So I'll just show you one layout where I have used robot and also the gantry robot. So this is my layout. So here is the robot which I have placed. I have used a tool, three-jaw chuck, which is going to pick my rotor shaft. This is the rotor shaft plant layout, where from this machine to end machine, the process is on fully automated with the help of robots and conveyors. So I'll just run it. So now in this machine, the rotor shaft is machine and this human picks it, and by conveyor, see, you can see without programming also in visual components, we can see how robot works. So here we can see its envelope also. Means you just select the robot and you'll get to know till where its reach is. You lobe around it. Basically, I want to say is in visual components you can see how in factory the robot works without colliding with any machine, without spending money on it. Means directly you can build your factory in visual components and you will get idea how the robots are going to work how with human and machines without collisions and without any accidents. uh, at worst case also, if any accident happens, you don't get any more money wastage. Means like on shop floor, if we do this practically experiment, we didn't get. Means if any accident happens, then the cost which we are going to face is our company will go in loss. But before going in loss, you can actually practically see it in virtual components. So this is my factory. This is rotor shaft line where you can see everything goes. From here, as one sir asked that how we can give process time and cycle time. So just you can select the machine, and here at the end we will have one process time column, right side corner. So you can give your machine's process time. This machine's process time is 115 seconds. Same way for this machine, it is 82 seconds. So you can give as per your convenience or as per your factory layout. These are gantries. These are working with it. Also robot programming we can do in it. But in this visual components, I don't think so. We need any robot programming, but because directly picking and placing, we can just drag from here any robot and we give this. I'll just show you how it happens. Yeah, already in visual components, we have many robots as per their company names, manufacturers. You can see Hitachi. These are some robots with different. So you can just drag and drop and build your factory. That's it. Thank you.
I have a doubt in my mind. Can I ask that?
We must have cleared the difference between VC and K. So, anyone have any doubt on this?
Sir, I have one question. Can I ask it?
Yes, please.
Yeah. So, as shown in previous presentation by Aarti, I want to ask like all the PLC machines and all that were shown in that presentation, all were included in the library, or it's like somehow we have put on somewhere else.
No, it is built in the library. That is why it is so popular product, and it has very good 3D capabilities. So you can even customize the CNC machine model of your own choice. Also, you can integrate in that. But ready-made catalogs, e-catalogs are available. So you will feel as if you are walking through your factory. So it becomes more realistic to your process layout what you have.
Okay, so the tools or the devices which we have in our library that are only usable, right?
Yes, yes, yes.
Okay, okay, got it.
I mean, all components which you see in your factory are readily available. You just need to pick and place and then build as per your process sheet. You have to just put in what is cycle time, setup time, breakdown history, what labor is required, how much time does it take. I mean, then simulate it, see the bottleneck, then check where inventory is lying. If it is, how do I need to increase the conveyor speed? Is it feasible? Whether bottleneck is shifting. So based on that, you can take a collective call of increasing your capacity and optimizing your resources.
Okay, so does this software evaluate the electricity supplies and gains also?
No. Only time.
Okay.
No physics. It's pure industrial engineering, robotics applications, and it's a one more or one advanced version of RoboDK you can call. So commissioning your entire robotic system can be possible using Visual Composer.
Okay, got it.
Yes, Parag sir. Hello.
Yeah. Is it included in the RoboDK or a separate, you can say software or separate license has to be purchased?
Please introduce yourself first of all.
Yeah, myself PV Good. I'm working as assistant professor in robotics and automation department
Where?
in MESCO, Wadia College of Engineering.
Okay. I mean, it is the same department where Chaugule sir is there.
Yes.
Okay. Great. Yeah, please tell me.
Yeah, so this new simulation software you talked about, so is it will be the same bundle with the robotic or a separate version or separate license has to be purchased?
Yes. We'll have to buy it separately, but we give bundle also.
Okay.
Because it becomes a comprehensive package, no? You have 140 robots in the introduction, and later on you have entire factory at your doorstep. So imagine what kind of a cost cutting or cost saving we do for our students, and you can give individual students to work on those, and a hypothetical program you can create. You can give one final year projects also. Now, Aarti, to whom you were talking to, says final year intern, and we just wanted her to explain you because we wanted to see that how quickly she gets updated with this product. She joined 15 days back, and now she is phenomenal. And we now got to know that the students exposing this software for 1 month, they can do miracle in their career. And if they can, talk like this in front of interviewer, I am damn sure that they can grab the job of say 50,000-60,000 rupees per month. And this is what we just need to expose to the students, that instead of wasting a lot of cost on hardware, why don't they give confidence on software first, make them confident on hardware, and then later they can do really miracle on machines.
Yes, sure.
We do take training also. So if you require dedicated training at your place, we take 25,000 rupees per day. So we can take the entire setup and then train your students also. Based on that, you can take further talk. we have internship program also, but that all are paid now. We take 15,000 rupees per month. Mr. Roy, can you put your mic? Yes, please.
अच्छा वो जो हमसे पूछना दिया था बुला के किसी ने पूछा था
Roy, ma'am, can you please mute your mic? Hello, Roy, ma'am. Yes, Parag sir, tell me.
Regarding the internships,
Yeah.
do you offer internship and what will be the procedure?
We take 15,000 rupees per month for the internship.
Okay.
Yeah. Anyone else? The cost of the product is 1% cost of your robot software or robot hardware. It is very affordable price. So I can send you the quotation. You please send me your inquiry on my email. I'll just drop you my email ID. Or you can send me your email ID in the chat box to whom you want a proposal or training. Back to you. Fine, should we conclude now? Great. Parag sir, can you provide feedback so that we can conclude?
Yeah. So really it was a very wonderful workshop, very basic insights regarding the RoboDK software and the other visual software which we have seen. I hope all the students will be benefited from the softwares and whatever the new cutting edge technology that is going on in the field of robotics. It will be very much helpful, and we are also looking for your contribution for our internship and some, you can say, guidance regarding the projects. We'll definitely get back to you. Thank you, sir.
Yeah, convey our regards to your entire MESCO family. Dr. Mane Madam from Electronics Department also had been to our Center of Excellence last month.
Okay, sure.
Yeah. Anyone else from the crowd, please? They want to share something? I think we can conclude now. Your next, what do you want to disclose or clarify? Should we conclude the meet?